Hi everyone, welcome to our talk on Pythons in Python, wildlife trade data analysis using Python. My name is Devan Song, and together with my collaborator Lee Terrell, we are excited to talk about wildlife trade data analysis using Python. The Global Wildlife Trade Network is a beast of a trade network. It is a multi-billion-dollar industry where millions of animals and plants are traded within and between countries for food, medicine, pet trade, gardens, zoos, and more. Along with climate change, deforestation, and fire, the wildlife trade is among the top contributors to the global decline of species. Not only that, the wildlife trade facilitates the spread of disease around the world, which is bad for wildlife, livestock, and humans. The majority of emerging infectious diseases that are of concern to humans come from animals. Finally, the wildlife trade facilitates species invasion, where non-native animals are introduced into ecosystems which are unable to adjust. To solve any of the problems surrounding the wildlife trade, we need to have data about the trade. So where can we get information online about the global wildlife trade? Two great databases exist online. The FAO, or the Food and Agricultural Organization of the UN, has coarse-scale data about trade between countries. For example, it tells you how many non-food live animals are traded, but not the species traded. On the other hand, CITES, which is the Convention of International Trade in Endangered Species of Wild Flora and Fauna, has fine-scale data which specifies which species is being traded. It has over a 40-year data set with more than 20 million shipment records. These can be downloaded from the online database in CSV format. To give you an example of what a row of data look like, let's examine this screen capture. In the year 2013, a shipment of white-tailed eagles, scientific name Heliaeetus albicilla, was traded to Latvia from the Ukraine. Along with this information, we have higher taxonomic information such as class, aves, which means it's a bird, and falconiforms, which tells us that this is a group with falcons and related birds. However, the CITES database is a really large database where one has to query and download multiple CSVs to access the data, and many rows of data are missing crucial information. In R, there's an excellent existing package called CITES-DB, which supports the analysis of CITES trade shipment level data. And we want to create a similar package in Python. Easy and reproducible access to this database is useful for people who work in industry, economics, public health, and species conservation. And these are our target audience. This package is also useful for students. For example, we recently conducted a course at the University of Rhode Island for network analysis of the wildlife trade. Finally, this package can also be useful for researchers with more quantitative and programming skills, as we provide streamlined access to download this database. So here's what we had so far for our package CITES. I will describe the two main components of this package. First, data compilation, and second, data access and analysis of the downloaded data. Here is a flowchart representing the steps that we take to produce a single clean data frame from online databases. PyCites downloads the entire database from the CITES trade database at this web address. In its raw form, it consists of many CSV files with missing data. All these CSV files are then merged into a single data frame, which then draws from another database called Integrated Taxonomic Information Systems. This allows us to computationally fill in any blanks the data has for taxonomic information and correct any errors. This also allows for us to use the most updated taxonomic information for a species, as these do change over time. This complete data frame with many of the blanks filled in can then be saved as a CSV file. So let's look at a realistic application of this package. If you are a practitioner working in the wildlife trade, it is likely that you would like to subset the data by a certain characteristic. For example, you might only be interested in trade between, say, US and China. Or you might be interested in only the year 2008. Our package allows for easy filtration of the data by your criteria of choice. In this example, we will subset all data rows with the genus Python, which we all know are large snakes that constrict their prey. Specifically, I want to extract all the data about pythons imported into the USA between 1996 and 2017, as you can see in the code above. Using my new subset of data, I can then go on to ask questions about the data using my metric or statistic of choice. For example, how many shipments are there of different species of pythons? In the first chart, in the bar chart, you can see how many shipments of 8 different species of pythons there are in our data set. You can also plot a time series and ask, how has the shipment of these 8 different species changed over the years from 1996 to present? With just a few lines of code, one can extract data from a huge database, subset, and create descriptive statistics with informative graphs. PyCIDES is work in progress, as we all are. We have 4 immediate goals. First is the improved handling of large multi-gigabyte datasets with out-of-core data frames. We also are designing an easy interface for non-Python users to be able to subset and visualize data. We hope to incorporate network analytic and visualization tools, which lend themselves very nicely to understand this sort of dyadic and relational data. Finally, we are interested to solicit feedback from students and peers and practitioners for additional useful features for this package. That's all we have time for. Thank you for listening. And here is the link to our PyCIDES package on GitHub. We invite you to peruse and collaborate and look us up on social media as well. Thank you very much.